Good afternoon, everyone. Hope you are having a great conference experience so far. My name is Partha Chakravarti. I am the head of security architecture, engineering, and innovation for Humana. We are a health insurance and healthcare company. About me, my background, I have been mostly in financials. I started my career with Merrill Lynch Bank, JP Morgan, Canadian Bank. This is my first healthcare and health insurance experience. Outside of work, I am engaged in the industry. I teach cybersecurity courses at Northwestern University as an adjunct faculty, and I am also associated with Cloud Security Alliance as one of their chair for key management practice. So with me, my teammate Sunil Arora. I will let Sunil to introduce himself quickly, and then we will get started on the topic.
Thank you, Partha. So my name is Sunil Arora. Currently, I'm working as Associate Director at for Security Architecture Department at Humana. I have almost 17 plus years of experience in industry, working in many financial institutions, healthcare, telecom, technology services. I'm active member of many non-profit communities specific to cybersecurity, IC2, ISACA, Cloud Security Alliance. And in terms of education, I have BS and MS in cyber security and information assurance, and currently I'm pursuing my PhD in cyber defense. Thank you.
Okay, thanks, Sunil. So before we jump into this topic, right, the thing that we started thinking about, we all work in cybersecurity industry, and we have tons of assurance program in our organizations. We have third-party risk assessment. We also invite like the big four vendors and partners to come and do an audit and find gaps. We do have our software testing and assurance like the SAST, DAST, and many tools. They find gaps. Then there are red team, purple team, blue team, penetration test, vulnerability assessment. It is kind of an endless thing. We have so many testing and assurance activities in our organization. Still, we are always trying to do the catch-up game. There is never an end to it. Every morning you see there's a list of like 20, 30, 40 items found, and we work hard, coordinate with tons of line of business and the CIO units. Once you are over those issues, then you already have like more issues coming up. So then we started actually thinking about, is it something right that we are doing, or we have to look at the problem differently? Right? Why we are investing in so many assurance teams and assurance functions, still we can never get rid of the gaps that we have in our environment. So after doing some brainstorming, we started correlating with the real world problem, right? When we have a fever, right, it's a manifestation of an issue that is underlying in our body, and until and unless we fix that issue, no matter how many fever medications you take, you are just getting rid of the symptom and it is reappearing. And that exactly happens in most of the organizations that I have seen, where we have the vulnerability management program, Qualys scans, and they are finding issues, you're remediating, it keeps reappearing. Then we started thinking about how to fix the problem at the root. And when we started investigating, we realized after looking into some of the patterns of those issues, we found that the security architectural pattern and the design standards, is there any problem that those are not getting adhered to, and as a result we are finding all those deviations, and we keep changing the manifestation of the issue, but we are not fixing the root cause. As a result, it's a continuous game. So then we came up with this idea that, okay, I probably need to start at the beginning, take a different approach, focus on our patterns, ensuring our reference architecture, design pattern, blueprint, secure configurations, and all of the stuffs, those are validated. If we do it, it cannot guarantee, nobody can guarantee that we'll be 100% over all of our issues, but at least it will ensure that 70 to 80% of the things that we are trying to address, that will be addressed. And 0 days and all, these are part of the game, we'll have to address it. But most of the things, repetitive issues, we don't have to do it. It will be acting as a problem management aspect of handling the issue, as opposed to a firefighting or incident management drill. You find an issue, remediate it, and just move your fire truck to a different alley, and then you find that there is another fire going on. So that's why we came up with this idea, let's do some architectural pattern validation. Now, before we go deep into architecture pattern validation, I have been working in security architecture for at least 17 years in many different companies. And I have a varying level of experience. The definition of architecture, it varies depending on your organization. Some places I have seen architects are called in when there is a product or problem management issue going on, and operations team is doing a firefighting, and that has become the job of an architect. And what are you doing at that point of time? You're basically remedying issue or giving some idea on what needs to be done, right? In some cases, doing an engineering validation, in some cases, creating a network diagram or security diagram, that becomes the job of an architect. What I found, there is no standard, there is no reference artifact or anything which says this is exactly what an architect needs to do. An architect is considered to be a subject matter expert. Sometimes you are troubleshooting issues, sometimes you are building a solution, sometimes you are, wait a minute, I'm too high level, I need to align some of the things which is aligned with the business objective, and I will be creating the PowerPoints, and down the pipeline, it becomes an optional thing. I'm creating tons of visual artifacts. I'm creating a lot of the PowerPoint document. If these are not implementable, if these are not helping anyone in building something, then it becomes optional. And in many organizations, at least I have seen, those architectural standards and artifacts became optional, and there is no validation if somebody is using it or not. Even if they don't use, you have some toll gates you put, which is a process check and control, and it can be just an attestation. Did you use the right reference architecture? Yes, I did. What does the production say? I have no idea to validate it. Now, if we continue doing this thing, then the issues like this will continue coming in. So the first step before we go deeper into how we start validating patterns in an automated, in some cases manual and other way, it is important to define the boundaries of architecture, what it is and what it is not, then come up with an architectural ecosystem. What we need to produce as architects, what are the inputs, what are the outputs, and in what part of the system development lifecycle that artifact or that configuration or that diagram, whatever we produce, that plays a role. Because if those things are not defined, architecture is such a loosely coupled term. Sometimes architects do program management. Now, is it an architect's job? What value are you adding there? So, the important thing is that what architecture does at a high level, architecture's job is to ensure the business objectives are met in a secure, compliant, cost-effective, and a timely manner. So, as security architects, which is working like hand in hand with enterprise architecture team, our job is to ensure we set a target, we set a vision that has to go hand in hand with business vision and business objective. If business is trying to do a lot of cost reduction or efficiency initiative, trying to embark on generative AI a lot, so the architecture vision on the security side is that we need to have a framework for generative AI, secure and compliant usage of AI. So we need to set the vision. Then we need to set a strategy how we are going to go there from source to destination. And then we need to create a roadmap because we know that it will never be a big bang approach, right? We will never be able to accomplish everything in one shot. So what it is and what it is not, architecture artifacts, again, defining the boundaries. Before we start validating something, we also need to fix what are we validating. If somebody is asking me to validate a host name in a firewall or any system device, is that going to solve my problem or something else I need to validate? Before I define my target, what I will be validating, we wanted to ensure what the architecture will be doing or defining the architecture lifecycle. That is part one of the conversation. And then we will go into the deeper things. So architecture is mostly coming up with repetitive design patterns. So that you build once, you reuse every time, you don't have to struggle because most of the places, whenever a business problem comes, there are process gaps. Architecture or even engineering is not incorporated earlier in the phase, so you always get a surprise and ad hoc, you try to come up with a solution to design something. And with the solution, when you're trying to come up with a solution, if you don't have the right reference architecture or the patterns defined, then there is no consistency. Depending on the individual who is solving this problem, one person will do it a way and another person will do it in a different way, and there will always be an overloading of the controls. As security technical person, right, we all are smart, we all can solve the problem in 20 different ways, and we all have a preference, believe me or not, as a technical person, to solve the problem in the most complex way possible to make life more complicated for user, where security is already being considered as a blocker. So we need to get out of that mode and try to keep it simple and make sure this is based on some of the standards that we need to define. So definitely architecture is not about talking about a security tool or a feature. It has to be kept at a high level, and we are going to talk about what we defined as our architecture operating model and overall SDLC, and would like to get your thoughts either during the Q&A or even after the session, and see whether it resonates, or if you have any feedback that we all can take back and incorporate to make it better. So security architecture ecosystem, it starts with defining the policies and the standards, and that is done by the GRC team. So we wanted to link end-to-end, starting from the policy compliance to architecture, to engineering, to deploy, operation, and validation activities, so that end-to-end in a dashboard, you have the full view. Why we are doing it, and if we don't do it, what will be the impact, and what is the security implication to it. It starts with further left on the GRC side, where you start defining the security policies and standards that is defined on the industry best practice, guideline, regulations, and industry best practice standard, and also obviously security regulations, those are coming in. Here, as architects, we get involved. We take those requirements, and again, those are not the only thing that we take to define an architecture standard. GRC is the bare minimum thing that we take, that we must do. And as security professionals, we add on top of it security capabilities that we know that we would like to add, because it will give us the protection that we'll be needing. And we also get some of the security intelligence and operational feed. When we are building a design pattern, a solution architecture, a reference architecture, if it is not incorporating that 360-degree view, start with compliance, get your operational challenges which are repetitive, how you need to solve with your solution, get your threat intel feed, incorporate that, and the technology capability library, right, that you are incorporating. Then the solution probably will not be covering all the aspects that we are looking at. Once we incorporate those, we started building a control library, and we have like numbering of those: domain-wise, network, endpoint, identity, mobile, IoT, you just name it. For everything, we have a definition of control library, and it also tells what level of threat or what threat vectors it is going to address if we implement that control library. So there is a clearly defined library that any architect coming in, that training is given, that okay, this is the map you have. Now when you are dealing with a situation, do a threat model, and if this threat is coming, this has to be the control you must incorporate. On top of it, depending on the solution and situation, you may have to create a defense in depth. That is some of the guiding principles. But do not overload or underload security control when you are designing a solution. So eventually created the control library and a corresponding reference to the threat library that we are dealing with. Then we start coming up with, this is the core of it, right? The architectural operating model. These are like 4 artifacts that we produce, and these are not just artifacts that it stays in a Word or PowerPoint file. Most of it, right, I'll put a disclaimer, not all of it, most of it can be coded, implemented, automated, and validated in our environment that we did the pilot. So first we start with security reference architecture, and the reference architecture is at a domain level, right? It is the higher level blocks. The example of security reference architecture will be the network security reference architecture, which incorporates your traditional data center DMZ, which also covers this micro-segmentation or hyper-segmentation need, which covers your third-party connectivity, which covers the remote access, be it a VPN or be it the newer version of Zero Trust Network Access, ZTNA, which is riding on the SDP principles, or a campus network, or a guest Wi-Fi, right? All those things, it resonates with everyone. No matter which company we work, the requirements are all the same. You have to build a guest Wi-Fi, campus, branch, third-party network, and all those connectivity. Reference architecture deals with those high-level components. What are the block-level components? What are the interfaces for each of these? What are the guardrails you must have when you are incorporating those? And that is the high-level, your artifact, or eventually a diagram. So this becomes the starting point when you start defining more granular thing which eventually can be coded in your engineering deployment. Another example of the reference architecture could be identity and access management, that no matter what we do in our organization, we are going to have an identity store, a directory or repository. We are going to have an identity and access governance infrastructure. We are going to have a proxy which is going to be the front end, going to do some authentication, authorization. We are either going to do a role-based access control or a policy-based access control or an attribute-based access control, right? So those guardrails at a high level are defined in the reference architecture when you are interconnecting those blocks. Second is architectural patterns, because this granularity, last 15 years, I worked with many companies. I found probably I didn't do a better job. It was missing in many companies. And after every input collecting and iterating it, we came up into this implementation that we are talking about. So security architecture reference patterns, you have the high level, kind of a block diagram or domain level diagram or information. And then what you do, reference patterns are use case specific. You have remote access reference pattern. Are you going to do it with VPN and VPN concentrators? Pre-COVID was acceptable. During COVID, we all struggled with VPN because we cannot buy rack and stack hundreds of concentrators ad hoc when the demand far exceeded the plant capacity. That time, those container-based, Kubernetes-based ZTNA became handy because on the fly you can scale up, scale down. And also, when you are giving the ZTNA-based access, you are not allocating an IP address of the network. Your segmentation issue is partly resolved, right? You don't have to invest heavily on the segmentation if you have that, right? You are limiting your overall boundary. Then there could be like many other controls. How do you have the visibility? How do you have the outbound access for the users, where it needs to go, how it needs to go through? So those requirements at a much detailed level are documented in the architectural patterns, which are basically use case specific. It can be a cloud access through your colo provider like Equinox, right? How you connect, do you put an IPS solution in the middle of Equinox's rack, or what else you need to do? So specific to a use case, how you solution, starting from that reference architecture, putting the high level guardrails, getting into that use case specific solution is the reference security architecture pattern. Then you break it down further, because if you hand over the security architecture pattern, it is still at a diagram level, right? Engineers will have different interpretation. Based on the interpretation, they may implement something, they may miss something, and that will not help you to standardize the deployment. And as a result, you need to be more specific, you need to go more granular. So what we did is that we came up with security architecture blueprints, and we further classified it two different blueprints. One is a technology blueprint, and second is a service blueprint. Technology blueprint, in this example, say we are deploying a Palo Alto firewall. Where does the Palo Alto firewall need to get implemented, how it needs to be get connected, how people will be managing. Do you need a jump host to manage it? Can you connect it with Palo Panorama or some centralized console where from you can manage it? Those level of details will go, right? And also what kind of rules you are allowing in the firewall. Any allowed, not allowed, right? Your TCP, UDP sessions, what is absolutely must you should block. Those kind of guidelines will come into the technology blueprint. Service blueprint we created because today's environment, most of the things are cloud enabled, and when we go to cloud, we are dealing with multiple services like Key Vault and many others. So specific to the service, whenever you have a requirement, you need to define how the Key Vault in Azure, for example, needs to be configured, that detailed instruction is there in our service blueprint. It can be a separation of duty, right? You must have a separation of duty to do this thing. Now think about it. Separation of duty is a high-level statement. It's a simple English. But how do you validate? And if you don't validate, what is the risk you are having in your environment? So we have to come up with requirements specifically defined and granular, which can be eventually validated with a piece of software code, right? So how do you strike the balance? 100% cannot be done, but most of the things can be done, and that we have actually tested out in our environment. And security configuration baseline. Secure configuration baseline is actually going like even further down. If you have a Red Hat Linux operating system, what should be turned on, what must be turned off as the secure configuration setting, those are defined in the secure configuration guideline. So I will jump into a couple of the slides, and when we'll go into the actual content, these are the foundation of a solid architectural practice. We clearly defined what we need to produce, what should be the input-output, what is the use case, where exactly it fits in the system development lifecycle, and what should be the control at what level of granularity, and how we standardize those things. Once that is there, you know what needs to be validated, right? The validation becomes easy. Opposed to telling, hey, go and validate everything is according to standard. We have done that exercise so many times, taking a document of policies and standards, going and interviewing 20,000 people. At the end, all looks good on paper, and the hackers unfortunately don't wait for our all look good and certified, certificate that everything is good, and we do have issues. Once these artifacts are there, then the security architecture validation, and we'll go into the details, it's a combination of things that we have to do, will eventually be hammering. I mean, you take those artifacts, you create the solution design, you create your application architecture, you build your overall infrastructure platform and solution, and then the validation practice, which is the focus of this session, is going to query against each and everything to ensure you are following the standard reference architecture. You are not deviating from that. You are making sure the secure configuration baseline is there and there is no drift against it. And then also you are validating the blueprints. So I will take a pause. One question first, it came, and I will hand it over to Sunil on the other side of it. One question came up when I was thinking about how is it different from so many tools you have, right? You have the Wiz, you have the Palo Prisma, you have Qualys, and so many different tools and technologies. They all are validating. The difference is, what is the scope those tools are targeting? Can the tool go into the level of the depth, and can the tool go to the further left where you defined what should be in your design pattern and configuration? Can the tool go into that level? If the answer is yes, then we wouldn't have needed this security architecture validation practice. It's actually a team that we established. After doing a lot of research, we found that those tools cannot go. They have a different target and different focus. And many times we are actually playing at the surface level and not detecting the repetitive and the systematic problems. And that is why we came up with this. I'm not going to go into the details. I talked about it. This is where more details around what should be there in which architecture artifact that we standardize, and it can be referenced. I touched upon this. This slide also talks about the same thing, where each component plays in and how we should be incorporating those in our design aspects. So before I hand over to Sunil, go into the depth of the use cases that we did. One disclaimer, most of the things we have done are done using automation and scripts. Because of the compliance and policy, I cannot share the script with you, but there are some examples we have given. These are pretty much the standard things, and it's an extension of those which we incorporated in our solution. So again, the same question, security architecture validation, why? Right? And this is the best slide. When I started conversation with my leadership, everybody was confused. We do have software application validation. We have threat and vulnerability management. Are we overloading something which is unnecessary? And what value we will be getting out of it? And this is the slide which we talked about. It's like a floating iceberg where we see only 1/3 on the top, which is application that we are interfacing with. We are so concerned with our SQL injection, our cross-site scripting, and many zero-day vulnerabilities and all, right? In the application and the software layer, we most of the time forget that there is a 2/3 underneath that water level that we don't even see, and most of the time we don't spend enough time to uncover and detect those. For example, if we are building and spinning up a cloud VM, are we doing it in a right way so that it aligns on the architectural pattern that we come up with? Are we validating it? If we are not, then the deployed solution that we'll be building, it will have the drifts and the vulnerabilities that cannot be detected at the top layer, no matter how many issues we are remediating at the top layer. If we are not fixing the foundation, we are actually not going to resolve the issue forever, like permanently the root cause. So this hopefully resonates and shows why we need to validate the foundational component, like the architectural pattern and the reference architecture and the design pattern, as opposed to looking into application layer issues and the application layer vulnerabilities. Both are needed. They complement each other. If I do the validation at the bottom, that may ensure a lot of the issues at top are getting addressed. But if we address only at the top, don't look at the bottom, then it is guaranteed the issues at the top will come, will be reoccurring, and we will be busy in resolving those issues. So I will hand over to Sunil to talk about what we did, and then he will be walking us through some of the use cases with some examples that we implemented part of our architecture validation.
Thank you, Parsha. Appreciate it. So till now we understood that why security architecture is important, and then why the validation is required. And if you look into our current state, many security leaders don't sleep well. And the reason is due to the following questions. One is that, are my expensive security controls are configured and working properly? The second is, are we remediating the critical gaps? So we started, if you look into the back history, we started with proactive controls, implementing firewalls, proxies, so on and so forth. And then we realized that it's not working well. There are still security incidents happening, data breaches happening. So we moved to, incident response side of it, that we realized that, okay, this is also important. We need to do, security analytics, SIEM, SOC. Then we realized that, okay, it is still going on. It's continuous. Then there's a lot of focus on vulnerability and security testing. Most of the time, you will see that those are false positives, misinformation. Half of the information, there is no context. They completely missing context and business context and risk context. There's no risk view to it. There are static vulnerabilities. We go, we fix it, fix in one system, one application. Then you realize that, okay, the next one is there. And then you keep doing it, and you see, in any organization, you can imagine hundreds of misconfiguration, part of Qualys or other operating system scan and vulnerabilities, DAS, SAST, they never ends, right? So those are some of the challenges with the security testing. And examples, for example, Parth earlier talked about SQL, cross-site scripting, or if granular level, they can validate that some tools or some components are deployed. But how they are deployed in correctly and is per the requirement, business needs, objectives, so on and so forth, they cannot do it. So the context is missing. And that's why we move to more of validation aspect of it, which is very targeted to the security objectives which we are trying to meet. Making sure that it incorporates that business context and security requirements, to making sure that we are not just looking that, is this setting there, rather than having that, is this setting there, is configured appropriately, designed appropriately, and implemented appropriately, and it's operating at the right level of maturity. And making sure that overall security posture is maintained. And I'll take an example of, let's say EDR. EDR, tool is deployed, but is it configured correctly? Is it protecting what we are supposed to do? It is doing the right level of security posture to my endpoint. So that's where we are going into deep into from the validation standpoint, following those building blocks which Parth earlier talked about, from reference architecture, pattern, blueprints, and configuration baselines.
Give it to me.
Thank you. This shows that how we can do it. There are mixed approach, and some of them may work for some organizations, some don't. So if you look at the picture, so earlier we talked artifacts. There are the building blocks which got into solution deployment. They are making sure they are being followed. They are really getting implemented. And then validation function is there once those are deployed, either part of the deployment or after the deployment, there's a continuous validation happening. And there are various options. Either we can do a manual validation. Certainly that's not the best way to do it. But it's good for first time. You want to start with that. You want to understand what is really needed so that you can go and mature and automate it. But it's time consuming and require a lot of efforts, which we guys don't get right in cybersecurity department. But then there's a sampling based approach, which is more focused to take some samples from one environment and try to validate it. It's kind of ad hoc approach. It depends on what type of sample you are collecting and then how much you are validating is, and so on and so forth. So that may approach is work in some situation, it may not work in some situation. Then certainly then automated validation. That is where we are all trying to achieve and mature so that we can code these requirements either in a script or other ways into using some mechanism so that it can do more automation. It's the kind of the best approach, fast, speed, and accuracy. The other is the guardrails, looking into our different patterns and blueprints, making sure that some of them can be coded in such a way so that we can validate their either parametric based or configuration based during the deployment, before the deployment. Even in your configuration static files, maybe you want to go and just scan them, making sure that it has the right level of configurations or right level of parameters and settings, so on and so forth. So that's one way. But again, as I'm saying, configuration parameters, so that it has its own limitation. It just go and look into specific things, but it cannot look into holistic thing of it. Then there is a governance aspect of it. Earlier Partha talked about the governance functions. It is also a part of or component of validation because you need to validate your design. You want to make sure the solution architects are taking these components and building the solution with those. So they are not building the foundation which you have not agreed to or you have not planned for it. So one of the things which we are doing is making sure that the design and architecture is being reviewed when they are being deployed or before they're deployed. So getting plugged into your design phase, making sure they are designing and architecting it well. We'll run through some, I already spoke about these manual and automated options. So here are the kind of a ecosystem which is built around this approach of security architecture validation. So one is those building blocks which we looked at earlier, reference architecture at domain level, patterns, use case level, blueprints is more granular. Now it starts touching your actual control. Then configuration baselines that go into detail of how the system or any platform should be configured. Then other component is environment and control. So you may have on-premises, then you may have one CSP, multiple CSPs, you may have SaaS providers. So it varies how the control should be configured. So we have to count into the granularity and the variation of it. Third is the data sources. To validate, you need to collect the data. How you are getting the feed, how you are getting those inputs, those could be multiple different ways. It's APIs, you may have some, and somebody may be logging in if you are looking into manual validation, somebody logging into the portal, logging into some system, collecting the data points, so on and so forth, or more automated using APIs, other scripting, and other processes. Then the fourth one is the results. How, and just not result, it's more a result and making sure that you are remediating the gaps and fixing the problem, not just at the one time, with one system. It's one time across your environment, so that you go back, look into your design, look into your building blocks, and making sure that you go and fix the issue at the root, not ad hoc. It's not like one time we fixed it, and then next day we come and same problem is coming again and again, and we are just repeating that endless cycle of remediating it. Now this slide's picture look very nice, and it provides that what are the different components if we want to start the validation function. So first it starts from the blueprint and patterns. Those are the base which defines what we want to see in our environment, and then taking those and coding them into depending on scripts, JSON, YAML files, it could be other coding mechanism, and then customizing it to our environment where we want to scan, and then going into some kind of automation. So there could be validation engine that is using a piece of software, using some tool or technologies that go and look into the environment, scan for it, and get back and tells you, here are the problems. Then you have some alerting mechanism which tells, can trigger real-time alerts and emails or some other kind of alerts in the dashboard and so on and so forth. Validation database is where you are continuously collecting those logs and making sure that you can analyze them and fine-tune as it mature and progress. So there is a feed to engineering team making sure that policy checks or validation checks are working as expected. So they are scanning the right context and they are coming back with the right answer. So there is a continuous fine-tuning to that. Also fine-tuning to our architecture artifacts as well, those building blocks, making sure that they are not defining something which is really not achievable or is not applicable to our environment, is customized and according to our needs and so on and so forth. And then certainly security operation teams, if there is any gaps and issues identified, they go and validate it, making sure that. So with that, let's jump into the first case study. We have two case studies. After that, we'll have one more. So this case study, if you look into, that is kind of a blueprint and having a requirement telling exactly what is required in a specific resource. Or in this case, we are taking example of Kubernetes, which has a Calico deployed, and now it says that Calico shall only accept traffic from user subnets. These are the user subnets. It should only accept traffic from these. Now you will see that there are multiple components. There is Kubernetes, there's Calico, making sure that the users, and you need to know what are those, exact manifest of files where these configurations are configured. So once you define that target, right, from the blueprint standpoint, then someone code it for us, and here the example is taken as a Azure function app, right? So we coded in either, let's say, .NET or JSON or some other language. Now the code is deployed in function app. Targets are defined. So we have, let's say, 150 and plus 200 plus our Kubernetes deployment. Now we want to make sure that they are only allowed, the apps are only allowed from the user segment, or the user segment is defined in that. So taking that, it goes check into specific files, making sure that these are the subnets only allowed in the configuration, but the action is into that, and look at the bottom screen. If the code is defined, let's say I think it's .NET or JSON or Python, that the expected values are these. So if these values are there, then it look good. If not, then there is a variation. It go back and tell you that, okay, I did not find this. It was expected to be this, but it's not there. Then it tells and generate alerts then you can do whatever you want to do with it, either remediate it, go move further, investigate it, and see how it is, that deviation is there. Then accordingly, it's go in metrics and reporting,
So
making sure that.
Sunil, just if this problem, this particular case, we have a multi-cloud scenario where we have a lot of Kubernetes instances. We also use Calico, Istio, and a lot of other open source tool here as well. And we wanted to validate, are those configurations properly deployed? Because when we run our container scanning as well as our drift management tools, those were finding a lot of issues in our environment, and we wanted to see, what is the problem? Is the problem in the engineering deployment scripts? When people are codifying those scripts, is anything is missing, right? So bottom line, what we are trying to show here is that we need to have the high-level validation checks. One of the check could be your connection should come from certified defined subnets. And how do we convert those high-level English statement into some manifest file? At the end of the day, your validation engine is only going to look at the computer logic, which is going to tell, do this if it is that. So converting that high-level statements, which are an extract of the design patterns, which are an extract of the blueprint, right? If you can just think about, like, when we started defining our life cycle, we started defining from a higher level and broken down to the granular level, starting with reference architecture to the pattern to the blueprint. Now, take the statements of the blueprint, which basically says this should be the way you should implement it. Translate that English statement to a computer understandable format, which is some sort of a manifest file, and then the validation can be done in multiple things. We don't have one single validation. We do have some homegrown automation. In some cases, we actually had to create some Python. In some cases, we had to create a different validation script. So this is a work in progress. We need to standardize a way so that it can use one single way of tool to validate that thing. But bottom line, take the requirement, convert it into a manifest file, have an engine, daemon, software script that is running. We have done it in multiple ways, and we can show it and prove it that it can be done, and then eventually generate a report. That shows the foundation, like if the implementation is done proper way. Now, what we can tell, while we were doing this thing, we found when our DevOps team were codifying the requirements in a Terraform, there were a lot of things were missing. As a result, every spin-up of that faulty Terraform code was generating issues which our team was chasing to remediate. And there was not end to it because we were not fixing the engineering script which was causing that issue. So this is one of the examples, and I'm sure, like Sunil, your next two other examples will be more specific, where we validate the network architecture also, right?
Thank you, Partham.
Should I go to the next one, or
yes,
like
please.
Anything else?
Let's go to the next one. Okay, so this one is, if you look into, is more holistic and focus on network architecture validation. So there is taking a use case, we want to make sure that users are able to access the internet through proxy only, right? That we want to check constantly, making sure that that's the only path the user can go out. That there should be no other workaround other than proxy, so that making sure that it has all DLP controls, content inspection, so on and so forth, and antivirus and whatnot. So in this scenario, using the same approach and concept, making sure that we are able to define that granularity into the script, we can code it so that it goes and first check it. Is it, from any system, are you able to ping or trace route? Can you go out? Are you able to reach to internet? And we have deployed a server, test server, so the internet is reachable, it goes and tests it continuously. The second is, it goes and look into, and might be in our firewalls, in our DMZ, we have not allowed, let's say, ping and trace route. So this will fail eventually. Then there's a port access as well, making sure that, okay, maybe ping is not allowed. Let's try with the ports. Are we able to go and scan this domain with this port number? The script has that coding as well. It goes, look into the, first ping, it failed, okay, fine, let's go to the next step, look into the port, is it able to scan it, right? It may or may not work, right, depending on an environment. Then the third is, okay, so fine, we find that, okay, network is not reachable, port is not reachable. Now let's look the connection from the proxy. Is it able to reach it? Is it able to establish a successful connection? So that gives, and this scenario is just an example. You may have more complex scenario. You may want to test it in some other ways as well, right? Depending on your network architecture. That, okay, yes, ping worked or did not work, then your port worked or not worked. There are other routes you may want to check it, right? So you can accordingly build those components part of it. So that shows that you take it, the scenario, not just the security configuration or a specific parameter, and just checking constantly for that without a business context. So that's what the validation we are doing with these, different use cases, coding them accordingly, making sure that they are, environment is configured according to that, referencing back to our building blocks, and so that from start to end, these are working in a symmetrical manner.
So we are into Q&A time.
Yes.
Probably we can skip the next use case, but the bottom line, this was a huge problem for us. There were thousands of VNets you will find in most of the organization, where you will find that Azure or AWS has a direct exit out to internet. And you have a proxy and the filtering device at a different segment where your VNets will not be peered, and you will have a local exit out. And if you have a local exit out, then you are definitely not doing all the filtering, and that is causing a lot of issues in your environment, right? So how do we validate the implementation was done properly as opposed to checking into each and every VNet? So that was one of the approaches we incorporated, how we validate this. Considering our time is a little less, we want to go into any sort of a Q&A, but anything else, Sunil, you would like to see, you would like to add? Otherwise, we'll jump into Q&A on the next.
I think before we jump into Q&A, I think this approach is yielding a very useful results. It does not mean this is the only approach. You may require some other environmental control as well from CSPM and other technology tools, but this is the one which is giving us the context and the risk view, so that we can look into a little more holistically rather than just having a one single testing of something which is ad hoc rather than doing a architecture aspect of it.
Right, and we are also looking at in future, right? In some cases, we are using RPA to automate a lot of the validation process. In some cases, how can we standardize? Because we have a mix of like Python, we have a mix of like multiple things, how we can standardize a little bit. Right now, we defined what should be our target, and depending on, we created whatever was available to get us faster to the validation thing, and we will be standardizing those. Then we are also in the process of leveraging generative AI to create some of those validation even scripts automatically for us, as opposed to like we spending time, and also generating a report on whatever it is finding, so that we can prioritize what we should remediate. So that's the next step that we are working on, but would love to, I know we have less time, but we can stay here till the next speaker comes, and if any question that we can answer. Thank you.
Thank you very much. Yes, please.
Thank you. Is this working?
Yeah, we can hear you.
Okay, thank you. Thanks for the presentation. It's very interesting. I just wanted to ask you, I'm trying to just kind of interpret the whole idea, the concept that you're coming across, but did you make your architectures, like your reference architecture, a structured data document like XML or YAML or something that you were able to start at the base level of validation that you seem to be describing? Is it like, instead of going creating Visios and Word documents, you start with like a YAML or something very structured that you could start this validation that you're doing?
Right, so you actually are talking about our target. So we are not there. At this moment, what we did, completely unstructured architecture artifact. We structured it like what should be in a reference, pattern, blueprint. In a reference and pattern and blueprint, we created some structure, which is some sort of a key value pair we need to validate. The blueprint, you need to have this, right? TLS 1.2 enable has to be yes and no. In some cases, it is not fully structured yet. What we are doing currently, the effort is taking that content and creating a manifest file which can be validated. So we still have an English language document, right, which is not fully structured, semi-structured. We are taking it and creating a structure with a manifest file which can be validated through some scripts, and that's what we are doing. We have a mixed bag. We haven't done it. We are probably 7 months into this project where we have some result, and now we are investing more into it to make it like more automated, but that is our target direction, right? If we can use some generative AI or maybe some other tool to create the output manifest file automatically for us, that's what we would be looking. Right now, it's human intelligence and a manual effort to create that script.
Okay. All right, thank
Eventually,
you.
we want to define that as a machine
But you
language.
got our target state, so
Yeah.
that's where we would like to go.
Yeah. Good question. Thank you.
Yes.
So
Yes, please.
for the test cases that you had, how do you implement those across a diverse technology stack? So I don't have my company doesn't have like a single way of orchestrating network rollout or anything like that. What are your inputs? Are you actually going against like the territory, which is what's actually deployed, or the map, which is the orchestration, which is intending to deploy it?
That's another great question and another challenge, right? I mean, like, as we are learning those, right now, what the team is doing, architecture assurance function, we have the requirement, what we need to validate and identify and fix. We are letting them to find out a mechanism. I mean, that is why you see in some cases, they are actually pulling APIs where the tool is providing an API to grab that information. In many cases, there are on-prem technologies, no API is available. We cannot do that, right? In some cases, we are actually logging in like through the code and trying to grab some information. And in some cases, there is no other option doing a manual validation, right? So we bucketize those things where right now, no way. These are the options we have. These are more automated. So that's why you see in the example, some are Python, some are something different. So basically, we wanted to create some value faster as possible. Then we thought that we cannot have the perfection. Okay, there's a red stop, so I'll have to stop. There is no perfection on day one, so we are iterating and making it perfect. We don't have an answer to that. We have a mix of like scripts from different tooling and technologies to make it happen, but that is we are collectively looking for how can we standardize. I doubt it will be standardized because vendors don't even provide one single way of doing it. So it will be eventually some sort of a service that we have to keep iterating on.
Very clear presentation. Thank you very much.
No, thank you very
Can
much.
we take one more
Appreciate it.
question?
Oh. Okay, we can probably talk.
Okay, we can walk.
Okay.
Okay, thank you.
Yeah.